Right now, as you watch this video, your device is performing millions of calculations per second. Algorithms you've never heard of are routing data packets across the globe, encrypting your information, correcting errors, and finding the fastest path through billions of possible routes. You know the names: Google, Facebook, Amazon, the companies that dominate the internet. But you don't know the algorithms, the mathematical formulas written by people you've never heard of that make everything possible. Today, we're telling the stories of the invisible code that powers your life, the algorithms that solved impossible problems, and the brilliant minds who never became billionaires, never got famous, but built the foundations of the digital age. Back in 1969, ARPANET, the predecessor to the internet, connected just 4 computers: UCLA, Stanford, UC Santa Barbara, University of Utah. They faced problems no one had solved before. How do you send data across unreliable networks? How do you route information through changing paths? How do you even know the data arrived correctly? Today, there are over 5 billion internet users and 50 billion connected devices, sending trillions of messages daily. And it all works because of algorithms most people have never heard of. Let me tell you about 5 of them. Our story begins in 1956, Rotterdam, Netherlands. A young computer scientist named Edsger Dijkstra is having coffee with his fiancée. He's thinking about a problem. How do you find the shortest route between 2 cities? Sounds simple, but when you have hundreds of cities and thousands of possible routes, the combinations explode. You can't check every path. You'd be calculating forever. In just 20 minutes, while drinking coffee, Dijkstra invented an algorithm that finds the shortest path efficiently. Not by checking every route, but by intelligently eliminating bad options as you go. Today, every time you send an email or load a web page, routers use Dijkstra's algorithm or its descendants to find the fastest path through the internet. Trillions of times per day. Dijkstra never patented it. He published it freely, and died in 2002 without ever becoming a household name. 4 years later, in 1960, at MIT Lincoln Laboratory, 2 mathematicians, Irving Reed and Gustav Solomon, solve a problem that seems impossible. When you send data, errors happen. Cosmic rays flip bits, electrical noise corrupts signals. How do you detect errors? More importantly, how do you fix them without resending everything? Reed-Solomon codes add mathematical redundancy to data. Not random backup copies, but carefully calculated patterns that let you reconstruct the original data, even when pieces are missing or corrupted. Think about it. CDs and DVDs play perfectly despite scratches. QR codes scan even when damaged. The Voyager spacecraft sends photos from 15 billion miles away. It's all Reed-Solomon error correction. Gustav Solomon died in 1996, Irving Reed in 2012. Neither became wealthy from their invention. But every digital device you own uses their algorithm thousands of times per day. Fast forward to 1989. The internet is growing fast. Different networks, different owners, universities, companies, governments. Problem: how does data cross between these independent networks? How do routers in AT&T's network know how to reach a university in Japan? Engineers Kirk Lougheed and Yakov Rector created BGP, the Border Gateway Protocol. It's how different networks agree on routes and how the internet stays connected. Here's the scary part. BGP is based on trust. Networks believe what other networks tell them about routes, with minimal verification. This has caused massive internet outages. Pakistan accidentally black-holed YouTube in 2008. BGP vulnerabilities are a national security issue. But it still works because the original designers prioritized making things work over making them secure. That trade-off built the internet and now haunts it. Then there's Paul Mockapetris. In 1983, he solved a problem that was about to break the internet. Computers use numbers, IP addresses. Humans use names like google.com. Someone has to translate. The early internet used a single file, hosts.txt, listing every computer. By 1983, this was collapsing. Too many computers, too many changes. Mockapetris created DNS, a distributed hierarchical system. No single master list. Instead, a tree structure where different organizations manage their own pieces. You type YouTube, and within milliseconds, you get the IP address. All automatic, all invisible. Every website visit, every email starts with DNS. Paul Makapetris gave it to the internet and is still alive, largely unknown outside networking circles. Okay, you probably know this one. Larry Page and Sergey Brin, PageRank, Google. But here's what's brilliant. Before PageRank, search engines just counted keywords. Page and Brin asked, what if links are votes? And votes from important pages count more. It's recursive, circular, elegant. Unlike the others, Page and Brin became billionaires. They commercialized their algorithm, but they built on all those forgotten ones. Dijkstra's routing, Reed-Solomon's error correction, BGP, DNS. Google didn't invent the internet. It just made it searchable. Here's the uncomfortable truth about these algorithms. They were designed by academics for a small, trusted network. Then came commercial internet, surveillance capitalism, and nation-state hacking. Systems built on trust were exploited for profit and control. We know these algorithms have flaws, security holes, scaling limits, but we can't easily replace them. 5 billion users depend on them. It's like replacing the foundation of a skyscraper while people are living in it. Some of these critical systems are maintained by tiny teams, by volunteers. There's a famous comic, a tower representing the modern digital economy, resting on a tiny block labeled a project some random person in Nebraska has been maintaining thanklessly since 2003. That's not an exaggeration. That's the internet. So why tell these stories? First, to honor the people. Edsger Dijkstra, Irving Reed, Gustav Solomon, Paul Makapetris, and hundreds more. They built infrastructure, not products. We celebrate the people who built products on top of the infrastructure, but we forget the people who built the infrastructure itself. Second, to understand fragility. The internet seems robust. It's not. It's a collection of patches and workarounds designed 40 to 60 years ago for a completely different world. Third, to inspire the next generation. Not everyone needs to build the next Facebook. We desperately need people willing to do the unglamorous work, maintaining infrastructure, fixing old protocols. The next Dijkstra won't get famous, but they will enable the next generation of innovation. Because algorithms are power, the kind that changes what's possible, the kind that lasts for decades. That's a different kind of legacy. Here's my question for you. If you could thank one person who built the infrastructure you use every day, who would it be? Electricity grid engineers? Water treatment plant operators? Drop your answer in the comments. If you want to learn more, I highly recommend Where Wizards Stay Up Late and The Innovators. Next week, we're covering the woman who invented the compiler, Grace Hopper. Don't forget to subscribe. To the infrastructure builders, the problem solvers, the ones who shared their brilliance freely, we remember. Thanks for watching.